The distance formula. In this video, I will be showing you how to apply the distance formula to find the length or distance of two given points. Suppose that the given 2 points on the Cartesian plane are A and B, and their coordinates are x sub 1, y sub 1, and x sub 2, y sub 2 respectively. The distance AB, or the length of segment AB, is equal to D is the square root of the square of the difference of the 2x plus the square of the difference of the 2y. Interchanging the x sub 1 and x sub 2, or y sub 1 and y sub 2, the result of the square of the difference of the 2x is always positive, and so with the square of the difference of the two y's. Let's have some examples. Example 1. Find the distance between each pair of points whose coordinates are given: A, 2, 4, and B, 3, 5. The distance is equal to the square root of the square of the difference of x plus the square of the difference of the y. Let this be x sub 1, y sub 1, and 3, 5 will be the x sub 2, y sub 2. Then, the distance AB, or the D, is equal to the square root of 3 minus 2 quantity squared plus 5 minus 4 quantity squared, is the square root of 1 squared plus 1 squared. The distance of AB is square root of 2 units. You may convert the radical into decimal form if needed. Example 2. Find the distance CD. C is at negative 2, 3, and D, negative 4, 7. Using the distance formula, negative 2 and 3 as x sub 1 and y sub 1, and the other pair of coordinates as x sub 2 and y sub 2. The distance CD then is equal to negative 4 minus negative 2 quantity squared plus 7 minus 3 quantity squared. Simplifying, that is, the distance CD is equal to the square root of negative 2 squared plus 4 squared. Then the distance CD is square root of 20 is 2 square root of 5 units. Next example, find the distance between each pair of points whose coordinates are given. Using the distance formula, assigning 2, negative 9 as x sub 1, y sub 1, and these coordinates as x sub 2, y sub 2, substituting the given. The distance EF is equal to the square root of negative 5 minus 2 quantity squared plus negative 9 minus negative 9 quantity squared, that is equal to the square root of negative 7 squared plus 0 squared, which is square root of 49 plus 0. Then EF is 7 units. Number 4. Find the distance between the pair of points whose coordinates are given: G, negative 4, negative 9, and H, negative 1, negative 5. Assigning this pair of coordinates as x sub 1, y sub 2, and the other pair as x sub 2, y sub 1. By the distance formula, substitute the given to get the distance GH is equal to the square root of 5 squared plus 4 squared, which is the square root of 25 plus 16, and therefore the distance GH is equal to square root of 41 units. Number 5, the vertices of triangle XYZ are x 6 0, y negative 3 7, and z negative 3 negative 3. Find the perimeter and classify the triangle according to its sides and angles. In order to compute for the perimeter, we have to find the length of each side of the triangle XYZ. So step 1, find the distance xy or the length of xy with their coordinates. Substitute the coordinates to the distance formula. Then xy is equal to the square root of 6 minus negative 3 quantity squared plus 0 minus 7 quantity squared, that is square root of 9 squared plus negative 7 squared, which is the square root of 81 plus 49. Therefore, the length of xy is square root of 130 units. Step 2, find the distance yz using their coordinates. Yz then is the square root of negative 3 minus negative 3 quantity squared plus 7 minus negative 3 quantity squared, that is the square root of 0 squared plus 10 squared, which is equal to square root of 100. Therefore, the distance yz is 10 units. Step 3, find xz, the third side of the triangle xyz. Using the coordinates of xz, substitute the values to the distance formula. Xz then is equal to the square root of 6 minus negative 3 quantity squared plus 0 minus negative 3 quantity squared is equal to the square root of 9 squared plus 3 squared is equal to the square root of 81 plus 9. Therefore, the distance xz is equal to 3 square root of 10 units. Then step 4, solve for the perimeter. Since we know already the length of the three sides of the triangle XYZ, the perimeter of triangle XYZ then is equal to the distance XY plus the distance YZ plus the distance XZ. Therefore, the perimeter is equal to the square root of 130 plus 10 plus 3 square root of 10 units, or in decimal, this is approximately 30.89 units. Step 5, we can now classify triangle XYZ by comparing the three lengths. XY is square root of 130, which is approximately 11.4. YZ is 10 units. XZ is 3 square root of 10. So obviously, triangle XYZ is Escalene acute triangle. Number 6, find the missing coordinate for the indicated distance D. 2 points, 1 y coordinate is missing. d is equal to 3. By the distance formula, substitute the given. 3 is equal to the square root of negative 4 minus negative 1 quantity squared plus 3 minus n quantity squared. Then 3 is equal to negative 3 squared plus quantity 3 minus n squared. Then square both sides. To remove the radical, we have 3 squared is equal to the square root of 9 plus quantity 3 minus n squared. Cancelling this out. Then 3 squared is 9 is equal to 9 plus quantity 3 minus n squared. Expand the square of the binomial 3 minus n. That is 9 is equal to 9 plus 3 squared is 9. Negative 3n times 2 is negative 6n plus negative n squared is positive n squared. Then equate it to 0. 0 is equal to n squared in standard form, arranging the term in decreasing order. N squared minus 6n plus 9. Factor the trinomial, that is n minus 3 squared. N therefore is 3. That's it. I hope you've learned something from this. Don't forget to subscribe for more. Bye.